Very good morning, one and all. Today, we are going to solve a simple circuit by using the Norton's theorem. Take down the circuit, find the voltage across this 15 ohms resistor by using the Norton's theorem for given circuit shown below. Take down the circuit. So here in this circuit, here we are having the voltage source, 75 volt voltage source is there. Here 60 ohms voltage source is there, and 75 ohms voltage source is there. And here 30 ohms and 20 volts, here 15 ohms. So the load resistance is 15 ohms, and and the point across the points A and B. So what is the first step in the Norton's theorem? To remove this load resistance, first we removed this load resistance, that is 15 ohms. After that, we need to find out the what is the short circuit current over here. Okay, short circuit current is nothing but a Norton's current. So how to which is the best way to find out the short circuit current here over this point is by using the mesh analysis. That means by using the Kirchhoff's voltage law or loop analysis, anything is. So here three loops are there. So the current flowing to the first loop is I1, the current flowing to the second loop is I2, and the current flowing to the third loop is I3. By using the mesh analysis in the loop 1, applying the KVL, so the current is coming like this. Current is flowing from minus to plus. That means minus to plus is raise. Raise is positive, so 75 minus this 60 ohms, 60 into, so I1 minus I2 is equal to 0. So if you simplify this further, we are getting minus 60 I1 plus 60 I2 plus 0 I3. So here I3 is 0, equal to minus 75. Take this as equation number 1. Similarly, in the loop 2, the current is flowing like this. So resistance, all resistances drop. So minus 60. So okay, so minus 60 into I2 minus I1. So next is minus 75 into I2. Next is here minus 30 into I2 minus I3. So the current is flowing from positive to negative. Okay, so the positive to negative is again a drop. Drop is negative. So minus 20 is equal to 0. So if you simplify this equation, we are getting this minus 60 I2 plus 60 I1 minus 75 I2 minus 30 I2 plus 30 I3 minus 20 is equal to 0. So further, if you simplify this, so we are getting answer as 60 I1 minus 165 I2 plus 30 I2 is equal to 20. Okay, so I3 is equal to 20. So take this as equation number 2. Now apply KVL in the loop number 3. So loop number 3, the current through this is I3 or otherwise IN. Either you can take I3 or IN, both are same. So here the current is flowing from minus to plus. So it is raise. Raise is positive. So 20 plus 20. Again, the resistance is drop. So 20 minus 30 into I3 minus I2. Okay, so equal to 0. Further simplifying, we are getting answers. So here it is no I1 term. So we are taking this 0 I1 plus 30 I2 minus 30 I3 is equal to minus 20. Take this as equation number 3. By solving this 3 equation by using the scientific calculator in the equation mode, so we will get the I1, I2 and I3. So I1, after solving, we are getting the I1 as I1 is equal to 1.58 amperes. Next is I2 is equal to 0.33 amperes. Next I3 is equal to minus 0.67 amperes. So from this, what is IN? IN is nothing but I3. So IN is equal to I3 is equal to minus 0.67 amperes. So that means the current direction what we consider is wrong. Okay, the current is not flowing like this. The current is flowing like this. That is the meaning. Now we found out what is the IN. Now we need to find out the next step is to find out the RN. Okay, R Nortons. So R Nortons, how to find out? So from that circuit, open circuit the current source and short circuit the voltage source. So here you see in this circuit we are having the voltage source, two voltage sources there, so there is no current. So we need to short circuit this voltage source and open circuit the current. So here we are shorting the voltage source. Here also we are shorting the voltage source. Okay, so just we are redrawing the circuit. We are shorting this voltage source. Here also we are shorting. Okay, now if you short this the this voltage source here, so the current will not flow to this 60 ohm. So current will always follows the low resistance path. So current will flow like this. So we are neglecting this 60 ohm resistance. So here you see, so here 30 ohms is there. Here as it is 75 ohms as it is we are taking, but we are neglecting this 60 ohm because if it is shorted here, the current will not flow to this. See, for example, the current is flowing from here. The current is flow to this 30 ohms, 75 ohms, and it will follow over the low resistance path. So compared to this path and this path, the current will flow to this. So there is no need of using 60 ohms. So we are neglecting this, removing this 60 ohms here. So now further we are simplifying. Now this 75 ohms and 30 ohms are in parallel. Okay, so parallel. So 75 into 30 divided by 75 plus 30. So further simplifying, we get to the answer as Rn is equal to 21.42. Now we need to frame the Norton's equivalent circuit. So how to frame the Norton's equivalent circuit? So whatever the current IN we calculated, no, that current IN we are taking next RN. RN that should be in the parallel, and the first thing we open circuited, no, that load resistance. So we open circuited load resistance. That open circuit load resistance has to added again here. So now we have added the load resistance again over here. Now we need to what is the given asked in the problem is what is the current through sorry, voltage across the 15 ohms, voltage across the 15 ohms. Now we need to find out the current across the 15 ohms. After that easily you can find out the voltage across the uh, 15 ohms. So current division rule. So current division rule. So what is the current division rule? So the current across the 15 ohms is nothing but the current flowing into this loop into opposite resistance. Opposite resistance is what? 21.42 divided by total resistance. 21.42 plus 15. Okay. If you further simplify this, we are getting the answer as minus 0.39 amperes. Now the current through 15 amperes we got. Now the voltage across this 15 amps is very easy. So current we got, no. So V is equal to I into R. So I current through 15 ohms into this 15 ohms. Okay. So the current to 15 amperes is sorry, 15 ohms is minus 0.39 into this 15 volts, 15 ohms. So here we are getting answer as minus 5.91 volts. That means whatever the current direction we consider here is wrong. So the current is flowing in reverse direction. And if the current is flowing in reverse direction, this current also we are getting current to 15 ohms also we are getting in minus. So current is flowing like this. So initially we considered like this, but now due to this answer, the current is flowing like this. Current to 15 ohms is 0.39 amperes. Now, what is the voltage across this 15 ohms is minus 5.91. That means the voltage across 15 ohms is 5.91. So the current is flowing like this. So here the notation is here it is positive, here it is negative. So the current is current flowing to 15 ohms is 5.91 volts. That is the answer for this particular question. Or otherwise, the current to 15 ohms is minus 5.91 volts also correct. But if you consider this diagram, the minus 5.91 volts is correct. So if I reverse this current, because it is negative now, here the current is negative now. So I reverse this. Reverse the direction of current. So this is plus 0.67 amperes. Similarly, so the current is coming like this and flowing to this two loops. So the current through 15 ohms also will be in the reverse direction. Initially we consider here, now it is in reverse direction. So the current to this 15 ohms is 0.39 amperes. Now, this is the answer. The voltage we already calculated. So the voltage to 15 ohms is 5.91 volts. This is the answer for this particular question shown in the figure.